Okay. I got a few announcements before we get into things proper. I'm trying to remember them all, Matt. So we'll see if I can get it. I got three things I want to make sure I mention. I may have started a little bit of a rumor about when you have a lot of submissions in AutoLab, how that affects you and what happens with that. In the 3 p.m. lecture, I even went as far to say, if you have more than 50 submissions for an assignment, you clearly don't know how to do that assignment. So I may have went a little overboard with that one. So let me explain a little bit. The number of submissions, when it's a case-by-case basis whether a lot of submissions is bad or not. If you're clearly using AutoLab as a guess and check tool, if you're using that as your compiler, if you're using AutoLab as your tester and you're not doing your own testing, that's the behavior I'm looking for. That I don't want to see. If you have 100 submissions and you're clearly just hitting AutoLab as your tester, that's no good. If you have a lot of submissions and it's just something silly, like maybe you couldn't get one of my tests, my incorrect solutions, and it took you, 5 tries to get the functionality correct and get most of the stuff done, but you just couldn't get that bit to flip to completion until like 50 submissions later, until you saw some little silly thing you did. You finally got that one last test case. That I don't care. Like that's cool. You learned, you made a lot of submissions, but that's fine in that case. In cases like that, I would look at your first few, see how far you got in those first couple, and if you made a significant amount of progress, hit some silly brick wall, and then made a bunch of submissions, that's fine. That's expected behavior. You're going to have that from time to time. Question?
So, can you explain what functionality does not pass all tests means? Because it's on Piazza, but I really heard it from
Functionality does not pass all tests. That means my unit testing that I wrote, you failed that unit test. You failed that test week.
So your code failed that.
Your code that you submitted, so you have your test that you're submitting, run against yours, mine, and my incorrect ones. I have my own test suite in the same style, the same testing that you're doing. I have mine that's going to be comprehensive, test everything, usually comprehensive, sometimes I miss things. I run that against your code, and if that doesn't pass all my test suite, that's when you get the did not pass all tests.
Would you get a 0 on moderator if you wrote a test case that fails your code? Because you didn't consider something about it? About the code itself?
If you wrote a test suite that fails my code?
Yeah, but it should be correct.
So this
Let's
is
say you didn't consider something about the functionality of the code itself.
So this is part of what I want to talk about. So if you didn't understand something about the functionality itself, and there's a big misconception here that I want to make sure I clear up. The correct and the score, the actual number that you get in AutoLab, doesn't have a whole lot of meaning to it. A lot of students are really stressing about how to get that bit to flip to a 1. That's an indicator that you're on the right track, but it is not the be-all, end-all. You got a 1, you got full credit. You got a 0, you got no credit. It's not like that. It's all of this is going to be reviewed when I look at the learning objectives. Did you complete this learning objective? You got a 0 for this lecture question. Let me go in and look at why. Oh, it was just one of my tests, my incorrect solutions that you didn't quite get. Oh, your tests were failing my correct solution because I worded the question weird and you interpreted it a different way than I did. It's all fine. That's not a huge deal.
I can't say the specific test case without violating AI, but like once I commented out, I got a 1 for the.
We can talk about that later. It's a specific case, but in general, I got a whole class here. I'll talk in general.
Yeah.
But I'll look at all that when I review the learning objective. So after this week of labs, we're going to have the first batch of information, everything for this learning objective. I'm going to look at all that information I have and make those decisions, learning objective complete, learning objective not complete. And I can look at all those situations. So if you're wondering how that's going to work, try putting yourself in my shoes and figure out how I'm going to look at what you submitted. So what I'm looking at is 3 bullet points. Somewhere in here. I'm looking at 3 bullet points. Now I need to figure out, can you do these 3 things? I have 6 lecture questions, a lab activity, and a TA interview to decide, can you do these 3 things? That's ultimately what I'm looking at. So we can talk all day about number of submissions and test cases and incorrect, correct solutions, and did you get the 1 on Autolab or not? But really, I have all that information in front of me. I'm a human being who's going to make a decision. These 3 bullet points, did you complete all 3? If you're missing one, giving you feedback, okay, you missed this one, here's some opportunities that you're going to have to complete that. And you will have more opportunities to complete these. This week's lab is the end of the minimal opportunities that you have for this learning objective, besides the final exam. But that doesn't mean you're not going to have more opportunities. My intent is for you to have many opportunities. I touched on this on day 1, but I want to expand on it a little now that we have some more context to talk about. So for example, testing. This first bullet point, this bullet point is not going to prevent anyone from passing this class. This will not be the only bullet point you miss in the course because you're doing testing throughout the entire course. You don't get this bullet point in these 2 weeks or in this lab this week. Well, every single homework is going to have you writing test cases. So if you show me a homework with rock solid test cases and you pass that homework verification, can explain your test cases, you can get this bullet point way late in the semester. Stack and heap memory. When we talk about linked lists, when we talk about trees, when we talk about immutability, we're still going to be doing memory diagrams with stack and heap. So I have plenty of other assignments that are part of other learning objectives. When I say extra opportunities, I don't necessarily mean extra assignments that'll be out there. But there will be other opportunities baked into other assignments where we're going to use these concepts. We're going to use these things that you now know. We can use them later in the course. Similar with object-oriented programming. We'll use object-oriented programming later in the course. So if you don't get those in those 2 weeks of lecture, those 6 lecture questions and that 1 lab and that 1 interview, if you don't provide enough evidence to show me that you completed those, or if you really didn't complete those during that time frame, there's going to be later assignments. We're going to use object-oriented programming a lot later on in the course. There's going to be more times for you to show me that you know inheritance, that you know polymorphism, just naturally through the other assignments. Plus, if you complete an application objective for a particular learning objective, so if you do the physics homework, but maybe you missed a few lecture questions, I mean, just put yourself in my shoes. I'm a human being looking at that, making a rational decision. I'm going to see that you finished that homework. Well, you probably understand references at that point. If you have a map storing your dictionary, did I say physics engine? Well, let's do rhyming dictionary. If you have a map storing your dictionary with all the words that you process from that file, and you have that in a state variable, and you're passing it, accessing it through multiple methods, and using that reference of that map, that's evidence that you understand references, so I can hit that bullet point with that. So I'll have a lot of information. The easiest way and the quickest way to complete a learning objective is just to do it by the end of this week's lab, just be done with program execution, and don't have to think about that learning objective anymore. But that doesn't mean that's the end of it. So, question?
So even though it doesn't affect your ability to earn the learning objective, it does affect your application objectives, right? So like improve your grades. So like if you miss like a homework, then
Missing homeworks, that's a different story. That's where you're improving the grade. You can miss a homework if you don't do the homework and the verification. If you're close enough, we'll still work with you, and you might have another opportunity to verify the homework. But homework's a different story. You can miss those opportunities. But the learning objectives, I put a big weight on those and said all 5 of these or fail. So I'm going to give you opportunities and try to make that as low stress as I can. It's still going to be high stress, just the nature of that. But I'm trying to make it as low stress as I can.
For those heap and stack memory diagrams,
Yeah.
are we doing it based on our code that we coded for the lecture questions, or are we doing it based on code that's given to us?
I'm not going to tell you what the lab is. You're going to get some code during lab, and you got to draw the stack and heap diagrams based on it. I'm not going to tell you what the code is right now because you can do it before lab. But when you get to lab, you'll get 2 programs. And you gotta talk about the stack and heap.
The interviews then too, right?
Yeah.
Yeah.
Hit that one. Hit that one. Oh, late lecture questions too. There still seems to be the misconception that the deadline is the deadline. The deadline's a pretty soft deadline. And I saw a thread on Piazza before lecture where if you don't submit a lecture question, you can still submit it late, but you don't get credit for it. And they're worried about credit. There was a poll wanting 8 lecture questions and some questions for double credit and everything. There's a lot of misconceptions here. The big one is there's no such thing as credit in this class. There's no credit. You're not getting points. You're not earning points or anything. You're just completing things and then showing me that you've completed the learning objectives. If you complete a lecture question late, yeah, it shows 1 on Autolab, then -1 or -2, depending on how late it was, and then a 0. Those numbers are pretty meaningless. They're mostly there just so I can sort the gradebook and get quick data to be able to process these learning objectives. But the numbers themselves don't really mean anything. If you submit, for example, if you submit 1 minute after the deadline versus 1 minute before the deadline with the same submission, I don't view those as 2 different things. That just means it took you another minute. I don't really care. Same thing for a day or 2. You still showed me that you know how to do that question. The deadlines are really soft in this course. So don't stress out with the deadlines. The deadlines are more of me saying, this is when at this point, you should be able to finish this question. If you can't finish it by that time, you know you got to do some catch up. But I'm not going to hit you with learning objective incomplete because a lecture question was late. Now, if all the lecture questions, you did all 6 of them right before lab, actually, I don't know, that might be impressive to me. I might if you can crank them all out right before lab. But, if they're all late, that's more of a time management issue. I don't know. It depends on the situation, though. But I'm going to look at all this evidence. So here's, let me just, I got to get to lecture, but let me quickly give an overview. There's 389 students in the class across all 3 sections, and I got to do all the learning objectives. I'm going to try to get them done by early next week. After all the labs, I'll process all the data. I'm not going to look at all these things for every single student. I'm going to look at, okay, 6 lecture questions, you did them all, okay, a couple were late, whatever. The interview went well, TA submitted a good report, and you have the lab activity, that looks good, glance at that. Okay, learning objective complete. I'm not going to look at every little situation. It's the borderline cases, that's where I'm going to start looking, okay, how many submissions did they make? Let me look at their 5th submission, because they made 100, how good were they doing on the 5th submission? That's where I'm going to start looking a little deeper for a subset of the students. Because a lot of you, I assume, I'm hoping half the class or more, I can just automatically say, yep, you completed this learning objective, and not have to dig very deep. And then there will be another 25% or so, I'm assuming, who didn't complete half the lecture questions or just gave up on me already, basically. Those are easy no's. And then everything in the middle, that's where I'm going to start looking. Okay, what's this specific situation for this student? What did they do? Let me see how they did throughout these. If it's not an easy yes or easy no, that's when I'm going to start looking and making rational decisions as a human, looking at everything you've done. Can you actually do these 3 bullet points? Nowhere in there is my thought process going to say, oh, that lecture question was late, and this one had a lot of submissions because I have a capital L in flashlight, and it took them a while to see that. Sorry about that, by the way. That's not going to factor into that decision. Yes?
So for the lecture questions for this week, does it count as the second?
Yeah, this week starts the next thing. So any other questions about this, about logistics and everything? My overall message is, yeah, I know that's set up in a stressful way, but please try not to stress. I'm going to work with you on these learning objectives. If you actually complete these 3 and you know in your heart that you can do these 3 bullet points, my goal is to have you not worry and not stress out. That's my job. Yes?
If you hit the point in our grader for the homework, but you're missing some of the tests, you give us the 1, but it still says something.
Yeah, so for the homework, if you complete the primary objective but not all of the testing, you won't just get a surprise 0 on that application objective. If you get a 1 on the primary objective, the one thing I'll guarantee you is that if you don't get the application objective complete, you're going to get some feedback from me or from the TA saying, here's what you need to do to finish the homework. So if there is a situation where we just look at your code and there's just something really off the wall. But if you can get the primary objective without all the testing,
Okay.
it's kind of whatever, The primary objective is the main goal. Can you use what you've learned to solve a real world problem? If you solved that real world problem and you didn't have to use my scaffolding to get there, not going to stress out. Not going to stress over it. Lon?
Question from Twitch.
Oh. Yeah.
Do the homeworks or application objectives have a soft deadline as well?
The application objectives, those are hard deadlines. You have to finish those homeworks before that deadline. Those are more strict. Those are more strict. I'll leave it at that. I really don't want anybody to, I missed one deadline, now I have an F in the class. I'm very conscious of that. I don't want that to be a thing. But when it's the difference between a B and a B plus, look, sorry to say, you got to work for that A if you actually want that. That's going to be more strict. All right, we gotta move on or we're never going to get to lecture. So today marks the beginning of the second learning objective, object-oriented programming. We're starting a new group of 6 lecture questions. There'll be a new lab in a few weeks, a new interview, new homeworks. I was hoping to have the homeworks released today, but I was getting this week's lab together. So hopefully by Wednesday we'll have the homeworks up. I'll give you the quick description of it. You have to build some functionality, finish an assignment without using control flow. No ifs, no loops. So how do we program and how do we get our code to make decisions without a conditional and without any loops, without any control flow? And we're going to talk about that all next week. We're going to use what's called the state pattern, state design pattern. We'll learn all about how to do that. It seems impossible at first, but we're going to learn how that actually works. So object-oriented programming is the first of 2 paradigms we're going to see. Object-oriented and functional. With this, we have 3 big things, 3 huge topics that we want to talk about. Inheritance, polymorphism, inheritance that we'll talk about today. Polymorphism we'll talk about Wednesday. An application of polymorphism using JSON and a strongly typed language on Friday. And then all of next week is this last bullet point, having a program change its behavior based on the type of an object stored in a state variable. The state design pattern, this bullet point is just saying, can you do the state design pattern? And this is all about doing exactly what the homework's asking you to do. Can you make decisions based on a type instead of a conditional? Instead of writing if, condition, we're going to say, hey, state variable, do your thing. And that type of the state variable can change, which will change its methods, which will change the behavior of the program. So this is what we want to do. Let's get into it. Actually, just to make sure, are there any last questions? And I see some Twitch chatter. Schrodinger's battery is going to always be a mystery. Okay. All right, inheritance. On top 2. So first lecture question. Why does this, it looks like so much text. I guarantee it, I promise it's not as complicated as the amount of text looks. I don't know, maybe, you'll let me know. So here, it's the same lecture question effectively in terms of functionality as Friday's lecture question. And I can't believe I did this. I'm still beating myself up over this. But if this tripped anyone up, I'm so sorry. I have a capital L in the middle of flashlight. Flashlight's one word. That should be a lowercase L. I preserved the typo just for consistency from the last lecture question, But yeah, that's a capital L in flashlight. And that's a prime example of, okay, I had 50 submissions, but it was because I assumed that was a lowercase l because it's supposed to be. Yeah, I'm not going to hold that against you. But I can't get back the frustration. If you were frustrated by that one, I'm so sorry about that. I can't believe I did that one. I saw it late last night, and anyway. All right, so we want to build the same functionality as the last lecture question. We have a boombox and a flashlight. We can swap batteries. We can use them, which drains the charge of a battery. But you noticed in that lecture question, there was a lot of shared functionality between a boombox and a flashlight. These two classes are very similar. Objects of those type are very similar. One of the methods was exactly cut and paste verbatim between the two classes. So this is a case where we can use inheritance and share that functionality, only write that code once, and share it across those two classes. And we're going to use something called inheritance to do that. So for this lecture question, we're going to create what's called an abstract class named electronic. That's going to have all of the common functionality between boombox and flashlight. And then boombox and flashlight are going to inherit that functionality from electronic. So anything that's the same in the two, we're going to effectively factor it out, put it in the electronic class, and then extend that class. And extend that class from our other two to grab that functionality. And then in boombox and flashlight, we're only going to write whatever functionality is different between the two. Any common stuff goes in electronic, and anything that's different goes in these separate classes. And then the battery class is unchanged. Put this in a package named OOP.electronics so it doesn't conflict with the other code. You'll be able to preserve your other lecture question if you have them in the same project. But make sure you're using this package, and make sure you put your new classes in that package. You can start with what you have already, and then start refactoring to get the common functionality in the electronic class. So let's see how to do that. We're going to talk about the type hierarchy. What does this mean? I showed this picture. Did I show this picture before? I might have removed that slide. But I meant to show this picture before if I didn't. What does this picture even mean? What's going on here? I'll show this again at the end to talk about what I mean there. All right, so we're going to build kind of the start of a game. We're going to kind of write the start of a game. We're going to build just some functionality. We probably won't get to the point where we finish the game. I don't know, maybe, but it depends. Probably won't actually build this game, but let's build some functionality that would get some of the mechanics of this game in here. So we want a player, multiple players with health and strength. They can pick up and throw balls, and the velocity of the ball should depend on the strength of the player that threw it. We won't build this functionality, at least not today. When they get hit with the ball, they lose health. And players can collect health potions to regain health. So, like a simple dodgeball game. Let's build some of the mechanics to be able to build this game. So first, let's analyze what objects are in this game. We're going to have player, ball, health potion. Those are the three objects we mentioned on that previous slide. So let's build these three objects and kind of review our object and class content from 2 weeks ago Friday. We can always use more review on objects and classes. It's a tough topic, and I burned through it in a lecture. So let's get a little more review. So an object can have state and behavior. We have these state variables, which can change with the object, and behavior, which are the methods that can be called on that object. And the behavior is going to depend on the values of those state variables in some cases. So if I have it doesn't even, my methods here do depend on those state variables, but I pass the reference. But so when I call these methods, I'm going to pass a reference to this, which then in the other class, the other object we'll see on the next slides, are going to use that reference, use those state variables to change that behavior. And I have all this state that I can have in this object. Everything I need to be able to control a player class, the location, dimension, like in the physics homework, and velocity. Then the orientation. I want to know which way this player is facing. Even though if you're working on physics homework, everything's orthogonal to the axes, I do want to know the orientation, so when this player throws a ball, I know which direction that ball's velocity should be set to. So we still want to know which way the player is facing in this three-dimensional space. Are they throwing a ball this way, even if they're physically orthogonal to the axis?
There's three of them because X, Y, Z, right?
Yes. Yeah, as a three-dimensional game. The ball, same thing. We're going to have some state and behavior. The ball, I want to know its location, dimensions, velocity, so it can move around in this space. It can exist in this space. It can take up space. And then its mass. If we want to say how fast this ball is going to be thrown, actually, I don't even use it here, and how much damage it's going to do when it hits a player, I want to know its mass to be able to make those computations. Again, we're not doing that. We're not building that part of the game. We just want to focus on the OOP stuff here, the inheritance stuff. But that's why we would want the mass. And then when the player throws this ball, so we had that use method, we pass the player reference itself. This is going to get that player reference and then access the player's state to be able to figure out exactly where to throw this ball, which ignores mass. Well, realistically, we would want mass in this calculation, but that's not the point of today's lecture. And then health potion, same idea. This health potion can move around in the world. It can take up space. It has a location. It also has a volume, which is going to determine the amount of health it replenishes. So I can have a potion of different size to determine how much health is going to be regained, and then make sure that we don't go over the player's max health when this is used. So we have 3 objects in our game, but this is a really boring game if we set it up like this. So if we're using objects, we can only have 1 player, 1 ball, 1 health potion. You're not going to want to play this game for very long. You don't even have another player to throw that ball at. You can only use the potion if you hit yourself with the ball. Not interesting. And that is why we use classes. We want more than 1 instance of each type. So we create classes, which gives us a way to create multiple objects of the same type. If I make these classes, I can have multiple players, multiple balls, multiple health potions. Use these classes each time I want to make a new object of that type. Now it's a more interesting game. We can have multiplayer. We can have multiple objects moving around in the space. A lot more interesting. So with this, we move any state that we want to be able to initialize to the constructor. So anything that can be initialized to the constructor, and anything that we don't want to initialize, or rather that we don't want the constructor, anyone calling the constructor to be able to determine, we'll put outside of the constructor and also outside of all the methods. And we can declare additional variables here. We can run extra code here. If we want to call methods in here, we can put any code we want in this kind of area outside of the methods, this area out here. So here we're going to create another instance variable named health. Just initialize it to the max health given in the constructor. So I can have players with different strength, I have players in different locations of different sizes, the speed can change. All these different properties can be different for each individual player. Same with the ball. Everything can go in the constructor here. We don't have anything that we want to initialize outside of the constructor. We don't have any code that we need to run outside of that. So everything's in the constructor here. Same with the health potion. Everything's in the constructor. And now we can use these classes to create multiple health potions, balls, players, like I said a few slides ago. We use this ball class, for example. We'll use the new operator, the new keyword, which is going to call the constructor. We'll give it all of the arguments to match the parameters. And then that's going to create ball objects, put them on our RAM stick, give us a reference to that ball object that we created using the class as a template, and then we can use these balls in our program. We can have them as part of our game and do whatever we need to do with these objects. Any questions on the review stuff? On objects and classes? Just a quick overview again. All right, let's talk about inheritance. So just like that lecture question on Friday, we notice the same thing here. Ball and health potion have a lot in common. These are 2 very similar classes. Can we not repeat ourselves? Can we not cut and paste a lot of code? And specifically, what if we want to add functionality to these? And what if we want to add more objects to our game that also have all that same functionality? So if we want to add like a compute momentum, we're going to add that method to each of these. There's a lot of methods that we would want in both of these classes. Any object that can move around our game, any dynamic object like the physics homework, we want them to have a lot of common behavior and common state variables, common properties. So each time we add those, we're going to cut and paste into each of these methods, each of these classes. And if we want to expand our game, maybe we want to add 5 more objects with all these same similar properties. We're going to cut and paste the ball class, rename it something else, paste it a few times, and then start changing things. And then I want to update all these classes later. It just gets to be a pain. It's to be very painful. And this is going to be the theme of these 2 weeks. We want to make our code, we want to write our code and organize it in a way that's easy to expand our code. We want to add that new feature a year down the road after our game was released so we can get version 2 out there. We want to make it very easy to add those new features. That's where inheritance comes in. We're going to take all of the common functionality out and effectively factor it out of these classes, put it in a new class, and then have both of these classes extend that class or inherit all the functionality, all the state and behavior from that class. So here I want to take everything that's common and put it in this inanimate object class. It's going to take all of the common state and behavior from these 2 classes and store all that common stuff. And this is what we call an abstract class. We're going to have a class with a constructor with all those constructor variables. And it's going to have 2 methods, but these methods have no definition. So I'm going to say any inanimate object is going to have a method named object mass that returns a double and takes no parameters, and a method called use that takes a player reference and returns unit. But I'm not defining those methods. Now this is perfectly legal. We don't have to define our methods. We don't have to give bodies to these methods. But we do have to mark such a class as abstract. So abstract means, hey, this class isn't finished, and you can't instantiate this. You can't create objects of type inanimate object through this class. Can't do it, it's not allowed. It's abstract, it's something that just can't really exist on its own. It's just an abstract class. That's not fully defined. So what we want to do is inherit all of that functionality. We're going to use this keyword extends. Inherit all that functionality from inanimate object, and then finish the class, finish those methods. So we're going to extend inanimate object. That gives us everything in the inanimate object class. And we're going to have this kind of special syntax where we're going to call the inanimate object constructor inside this declaration line for our new class. So our class ball is going to have its own constructor and its own constructor parameters. It's going to kind of forward some of those parameters to the inanimate object's constructor. And these parameter lists don't have to match. We can have different, like we have mass of a ball. We don't have mass of an inanimate object. But we can change these constructors. But we do have to provide all of the arguments for an inanimate object that don't have default values. We do have to provide all that information to be able to instantiate that. Question?
So that's what, for the test that we do that and abstract.
Oh, yeah. Yep. So when we create a test suite and we extend fun suite, we're taking all of the functionality from fun suite, adding it to our test suite, and that's how we can say like test and have access to that. It's because we inherited that from fun suite. Yep. Yes.
You did that whole extends inanimate object and then the parameters. Is that also just like pulling the parameters into the new child classes functionality too?
So this is.
Dimensions and the extends inanimate object.
So these So the ball class, notice I didn't use val or var here. The ball class does not declare these variables. I'm using the same names, but because of our scoping, these values are going to be forwarded here.
Is your class
And-
ball a child class of the inanimate object?
Yeah, it's an extending class, yeah. It's a concrete class of type inanimate object. But these variables, I did use var here. So these variables are declared in the inanimate object class. These variables here don't actually exist after the constructor, the ball constructor is called. These values are just forwarded here. And these variables are part of the inanimate object class, which is inherited by the ball class. So the ball has location, dimension, velocity, but it's not using those from its constructor. It's just passing the constructor values forward. A bit of a technicality. We don't have to think about that too much right now. But we do get all those variables. And now we get all of the behavior as well. So we get the behavior of object mass and use player. But this behavior doesn't exist. So here is where either we make ball also an abstract class, or we implement that behavior. So here we're going to have definitions for our classes. We're going to use this keyword override. Oh, my indentation. We're going to use this keyword override, which says whatever behavior what we call superclass, whatever behavior that class had, override it with this behavior. And in this case, there's nothing we're overriding, but we're still using the override to say, hey, this is something that exists in my superclass. Let's override that with this behavior. And now I'm given that definition of object mass. Same with use. I'm going to override whatever behavior was there with this new functionality. So now since we implemented both of those methods, they have definitions now. Now we can create instances of the ball class. We can create ball objects, and ball does not have to be abstract anymore. But we do have these methods implemented. Oh, I got ahead of my slides. And then we do the same thing for the health potion. So we're going to do the same thing. The one of the differences with health potion, we have this extra variable volume, which we're going to declare using val. So volume doesn't exist anywhere else, and it's something that we do want to access, that we may at least want to access outside of the health potion class. So I want to make that variable, that value, visible to the outside world. Maybe a player has a limit to their inventory by volume, and you want to know how full their inventory is and things like that. So you want to access this volume where the ball's mass. Oh, there it is. I knew that was somewhere. This should return mass at this point. The ball's mass is only accessed from inside that class, and anyone else is going to call object mass to access that. So we didn't have to use val or var there. We didn't have to make that accessible to the outside world. But volume will make accessible here. Location, dimension, velocity, we all made accessible up here. All right, but why? Why would we bother? There's the one answer of, we had less typing because we can share the code. But there wasn't a whole lot. The argument can be made here for this specific example. If we're not expanding and not looking for the forward, this is a lot more code than we had before. So why did we even bother? We just ended up with more code, more complexity. We have an extra file, so why? Well, where this really comes in handy, one place where this really comes in handy is when we want to add functionality. So now each of these methods, each of these classes has a get mass, an object mass method, and we can use that mass. Maybe we want to use that mass to compute its momentum. So they both have mass, they both have velocity. We can compute momentum, but we don't want to have to put these, as these methods get larger, we don't want to be cut and pasting this in every class. So we're going to put this just in the base class, just in the inanimate object class, and that functionality is now inherited by both ball and health potion. We wrote one method, but now we get that method in multiple classes. And that's where we really get to start leveraging this. Once we start getting more and more code, we don't want to duplicate that in every single class. Especially if we want to update. Maybe we want to change the way we're computing momentum. It's not the best example. But we want to change the way all of these classes behave. We go into an animate object, make a change, and it's reflected in all of those classes without affecting their other behavior. So a health potion still heals, a ball still can be thrown, but every inanimate object can get updates from this class. And if we want to make more types, like I mentioned earlier, we want more features, more different types of objects in this game, extend an animate object, and then only write the code that's specific to that object. And of course, implement object mass and use. If you're doing physics engine, and you want these inanimate objects working in your physics engine, well, guess what? Just have inanimate object, extend dynamic object, forward those two arguments, and notice it's a subtlety, but I'm not using val and var for these two anymore, or velocity, because those are defined in dynamic object. Dynamic object has the vals and vars for those. But now I extend dynamic object, give dynamic object all the information it needs to do its thing, and now every single one of my inanimate objects work with the physics engine. Now my health potions are flying around the game according to my physics engine. The balls are being thrown according to that physics engine. They can detect collisions based on that physics engine. We didn't write much code in the ball class itself, but it gets all of that physics. You have a game world. You put all those objects, those dynamic objects in the game world. That game world, that physics engine, nowhere in your physics code did you ever write health potion or ball, but those two classes work with your physics. All of your physics are applied to those objects of those types now because they extend dynamic object, so they are dynamic objects. I mentioned this. The keyword this. I do want to mention this. Thank you, slide. I knew I made you for a reason. The dynamic object class, in this class, there is a velocity variable, a state variable that's declared using var inside dynamic object. Since we extend dynamic object, we extend that state. We have that state variable too. So in inanimate object, we can access that by using this dot velocity. This comes up in your lecture question too. There's a big reason I made this slide. This is a brand new slide. This dot velocity, I can access that velocity from the dynamic object class that I inherited. So I inherited that variable. Now I have to change this name of this input. If this was also named velocity, when I say this dot velocity equals velocity, well, both of those velocities are in the same scope. They're both this dot velocity. So Scala's going to get confused. It's not going to know which velocity we mean, and it's just going to reassign the velocity from dynamic object to itself. So we have to give this parameter a different name to distinguish it between this velocity that I inherited from the dynamic object class, and then assign it this velocity from the input from the constructor of inanimate object, then assign it to this velocity, this dot velocity from dynamic object that we inherited. The same doesn't apply in the constructor call. In the constructor call, we have a lot of duplicate variables floating around. That's all valid in the constructor. It's just going to forward these to the constructor call. But if we're outside the constructor, if we're floating around in this space outside of the methods, this dot variable name, if there is a variable of that name declared in one of the base classes, in any of the inheriting classes, that's the variable it's going to refer to. So we have to be careful about that. You just name this a different value. That comes up in your boombox constructor. Don't use the variable name battery in that constructor, because you're going to inherit a variable named battery from the electronic class. So you're going to have this dot battery. That refers to the battery variable that you inherited, and in your testing you need to refer to that battery. So in your boombox constructor, that parameter can't be named battery because you won't be able to do this style of assignment right here. You won't be able to do this if you have a boombox input named battery. Because how do you distinguish between the two variables both named battery when they're both this dot battery? You don't have a way to distinguish between them. I mean, we do, but we don't want to talk about it. It's too complicated, too much. So here's our inheritance tree. We have dynamic object being extended by inanimate object, being extended by ball and health potion. And just a reminder, and that's what this tree is saying. We have any class, so every single class in Scala extends any at some point. We have two branches from that. Any val extends any, and all of these types extend any val, which implies for our purposes that they're going to go on the stack when they're created. And again, for our purposes, if you want to throw string in the mix and pretend that that's in there, that's fine. We'll get to that when we talk about immutability. We'll talk about that more in depth. Everything else is going to extend any ref, which means it's going on the heap. If you create a class and you don't extend anything, it implicitly extends any ref, and you get methods like toString and dot equals, which is called through equal, which defaults to comparing by reference. You get that functionality from any ref by that extension. And yeah, that's it. And back to the lecture question. All right, 1:50. I'll see everyone Wednesday.